In this episode, we're going to look at a new multimeter I got from Banggood. Now, multimeters, dime a dozen, right? They all do the same thing, right? Wrong. This one has a feature. It's an insulation breakdown tester. So it can generate up to 1,000 volts and check for leakage. This is good for checking for, well, power line leakage, breakdown in windings of transformers, breakdown in windings of motors, and so forth. Let's check this one out, put it through a few quick tests. This is a digital insulation tester. This came from Banggood. I haven't opened it yet. The package was kind of beat up when it arrived, but I'm sure the unit itself is okay. In the box, we have the meter and some accessories. Let's take a look at what we've got. Comes with the usual stuff. It's got these nice clips that you can clip on, and they provide good insulation. 1,000 volts is the rating on the insulation here. Temperature probe, and of course the regular measurement probes. This is called an insulation multimeter. So let's look at the specifications, see what exactly it does. You know, here it says, during insulation resistance testing, the instrument outputs a voltage ranging from 50 to 1,000 volts. Do not touch the output terminals or the metal parts of the test probes to avoid electric shock. So this thing actually will generate high voltage, and you can set it to what you want to test for breakdown, and it will generate a high voltage out here. So we'll test this. We'll see. I'll see if we can generate 500 volts. We'll measure my other meter with it and just see what we can get out of here. So let's just plug this thing in. First thing we'll do is we'll do the high voltage testing, and I won't put it on my meter. Like, I won't blow up my meter or anything. I'll put it on a voltage that's low enough that my meter won't explode. DC 1000 volts, 750 AC. So this meter will handle it. We'll see what kind of voltage this thing produces. Okay, for testing that portion, we'll turn on my meter, my other meter, and we'll clip the probes down here too. Positive and negative terminals. So we'll set it for 50 volts. And I guess I have to hit test. And it does. It puts a voltage out there momentarily, and it'll tell me what the if there's any resistance breakdown on here. So it does the test. It does do the 50 volts. You'll see. If I go to 100 volts, it's going to send 100 volts down. It's actually, the polarity seems to be opposite, saying negative. 250 volts, and indeed it did 250. I could put this on peak mode. We'll test it to 500. I'm not going to go to 1,000 on here, but I'll do 500. 500 there. See, it generates a pulse. And I guess I could go to 1,000 if I really wanted. This meter says it will handle 1,000 volts. But I'm not going to take it to 1,000. I'm only going to take it to 500. That's how these resistance or breakdown meters will test. So a conventional multimeter, for example, measures ohms, volts, test diodes, test the temperature with your temperature probe, measure your AC and DC voltage, measure hertz and so forth, the frequency. The difference between a regular meter and this, the breakdown tester, as I previously explained, it can put a high voltage pulse across an item that is being tested. For example, if I want to test my transformer to see if there's any leakage between the primary and the secondary, I can connect one lead to the primary and connect one lead to the secondary. And now I can proceed to do the insulation breakdown test. Press the test button. It will send a voltage down and see if there's any leakage between the two. And if there is any, we'll be able to detect it here. And I can progressively increase the voltage between the two to see if there's any short. Now, for example, if I were to place a short here, we would see it. I can take this up as high as 1,000 volts. So what I'm going to do now is I'm going to provide a 1,000 volt pulse between, this is just a regular magnetic transformer. One side's on the primary, the other side's on the secondary. If there's any breakdown in the insulation, it will show up as a fault. but because there is no breakdown between the insulation, it's showing overload. They're generating 102 volts. Right, so this will keep the voltage on. And I'm going to do that. I'm generating 256 volts across these terminals. So if I were to touch them, I'd get a bit of a jolt. I can do it with 500 and 1000. I wonder what would happen if I put a capacitor on there and crank this thing up. Should we do that? Should we just for shits and giggles? Let's just put a small capacitor on here. A sacrificial capacitor. Okay, let's just put the sacrificial cap on here, and we'll turn it up. We'll see what happens. We'll blow up. It probably will blow up. Let's go for the gusto. Let's crank this thing to full power, and we'll turn this thing on. It should go kaboom. Oh no, it's shorted. It's only 8 volts, and it's showing 0 ohms. Yeah, I think I killed the cap. Yeah, we killed this one. It's now got an 8. It's now got a short across it. Notice when I disconnect the probe, the voltage goes up to 1018 volts. And I see the voltage went way up. So voltage is, if I turn it on, it's got 1000 volts across there, and if I touch it to here, I've just killed this capacitor, because the voltage, as you can see, 1000 volts there, the voltage just dropped right down. I just killed this capacitor by putting 1000 volts across it. So it's kind of useful, and the capacitor is actually feeling warm. I think if I put the resistance across here, it'll probably show it's shorted now. Yeah, 15 megohms, 8 megohms. Yeah, see, I killed this cap. Sacrificial cap. I killed it. So the whole concept behind a breakdown test like this is, if you've got a transformer, for example, or a motor winding or something, you don't know whether it's any good, you can connect your winding up to one probe and connect the other one up to either the secondary, like connect one to the primary, connect one to the secondary, or on your motor windings, connect one to one winding, connect the other to the second winding in a motor. So if you've got your, for example, where your capacitor goes, I don't have a motor. I don't think I got a motor around here that I can demonstrate that on. But that's the whole idea, is that you can put a high voltage across, and right now, of course, there's no breakdown on here because there are 2 separate windings and the isolation is good. The modes it will read in is relative mode, pi is polarization index, and dar is your dielectric absorption ratio. So if we put it in, that's pi, we put it in pi and test it, it's going to give me a reading of 8.5, 8.9 points going up at 1000 volts. And if I switch that off and I switch it to, this is dielectric absorption ratio, DAR, this will give me an idea of how the dielectric is holding up. And is it breaking down? And this is obviously having an effect on the transformer because the numbers are changing. But that's at 1000 volts, which is, this transformer is just 120 volts down to 7 volts is the output, 7 volts AC. But that gives you an idea what the meter's for. It's designed for testing things, testing motors, transformers, anything that there could be a breakdown. Even between like your radio and a chassis, right? See if this what your isolation is between your hot circuit and your ground. If I put this across the transformer itself here, I don't know what to expect here when I put DC across here. We'll put some voltage on here. It'll probably damage the transformer, but we'll see what happens. Or it might even just give me no voltage reading here. I got zero ohms, but then the voltage is down to 4 volts because the current is very, very low, right? So it doesn't have a lot of current on it, but it will measure the breakdown. If there's insulation that's breaking down, that's what it's designed to detect. This is DC voltage measurement. I'll just clip it on. My other meter's on there now. 6.84 volts is what the power supply is set for. And this one's saying 6.828, so close to 8. 6.839, 6.826, so it's fairly close. As I raise and lower the voltage on the power supply, we'll take it up to the maximum. 32.19, 32.15. So it's off by a little bit. The reading slightly low. 4 100ths of a volt low. And I know this one's accurate because my fluke tracks exactly. Take it down to about 13.8. Got an extra digit of accuracy on the lower voltages. 13.809 versus 13.82. So you got that extra digit of accuracy on it, and it's fairly quick. So it's what's called a 4.5 digit. You got 4 digits, but if it's down, right, if it's less than 2, the first digit is less than 2, then you've got basically 5 digits, right? Because this one can only produce the number 1. When you get to 20, it's going to drop the decimal point back. So now you're down to just the 100ths of a volt. Now you're down to the thousandths of a volt once it kicks back and moves the decimal point back. To measure AC, I have to switch the meters to AC. Now this will be whatever is coming out of my variac when I turn it on. It gets up a little high, 126.6. I can adjust the variac down. 80.5, 80.6. Yeah, there it's tracking pretty good. Accuracy wise, I have no issues with that. Crank her all the way up. And take my bench up to 153.3, 153.5, which one you want to believe, but they're both pretty close. It has a desk stand, so you can prop it up on your counter, on your desk, for easy read. It's got a nice display. I like the display. It's huge. And I believe there's a backlight on here too. If I hold down the hold button, it will turn on a backlight so you can read it in the dark. It's got a couple of LEDs, and it's also got a light on the front so you can see what you're doing. What's under here? Is that a port? Oh, there's nothing. I guess it's a feature for others. You can hang it up. There's a hook on the back, so you can hang it up on the wall. That's a good idea. Put a little hook on the wall, and then you've got your meter just hanging there. It's a kind of a rubberized plastic case. It almost looks like it's in a secondary case, but I don't think it is. I don't think this is a secondary cabinet, is it? Let's see if it'll pop out of here. I think it's just the actual unit itself. I don't think this is like a case. Oh, it is a case. Okay, that's interesting. It's got a case that, you know, that's why it feels like rubber. It's got a rubberized case to protect it, the plastic, and it's actually snapped right on. So it's not one that's designed to come off. In the back here would be where I guess the batteries live. Let's see what it takes for batteries. Surprise in 5, 4, 3, 2, 1. Oh, rechargeables. It's rechargeable. Where do we charge it up? These are obviously going to be nickel metal hydride batteries. They're not going to be lithium, that's for sure. Oh, these are lithium cells. Holy smoke. These are lithium cells. 3.7 volts. I was not expecting, I thought these were for sure were going to be nickel metal hydride or something, and that is probably what that other accessory was that came with it. That is the charger for the lithium cells. Yeah. Okay, I wasn't expecting that. I was expecting this to have just like regular AA. These are AA size cells too. They're the same size as the AA cell, but they are outputting 3.7 volts. I was not expecting that. But here's the voltage of these cells. So 3.99, that's fully charged. They are rated at 3.7, 500 milliamp hours, 1.85 watt hours. This is a charger. You have to take the cells out in order to charge them up. This is going to be the charger for these cells. It's a 3-cell lithium charger. 10440, 10450, 14650, 16340, 16650, 18350, 18500, and 18650. Those are the cells that we'll take. So you just drop the cells in here. I guess when they're fully charged, they will turn green like that when they are fully charged. Now the advantage to that is, well, they're rechargeable and they're lithium, so they're going to last a long time. The downside, of course, is you can't just put regular AA cells in. This meter does indeed operate on 12 volts. And the reason it's going to do that is, again, because of the generator, the high voltage generator that's in here to generate the breakdown. So we're starting at a higher voltage, which is easier to step up a higher voltage than, say, a low voltage. So no, you're not using regular alkaline cells in here. And according to the manual, no, it does not accept anything other than the lithium cells. I'm going to pop the case off this thing. I want to take a look inside the meter itself, and then maybe we'll do a few more tests on it. I mean, the ohms and volts test, I don't know. I've done the volt test, but the ohms and other tests, do we need to do that? Maybe. This was more of a strength of this meter, is that it can check for breakdown on wire, insulated cable, motors. That's normally where you would test this. Transformers and motors and stuff that could have an internal short is where a meter like this would be most useful. I guess you could test long, like internal wires. If there was a short or breakdown in the insulation, you could check that to add up to 1,000 volts. There is the inside. Here's our little transformer to step up the power for the breakdown test. So we've got a light, we've got a couple of ICs here that look like they have the information has been removed from them. I don't see any numbers on here. Do you guys see any numbers? I think the numbers have been taken off. That one's got a number on it, but this one has the number's been etched off or milled off, one of the two, which seems to be quite common for companies trying to protect their intellectual property from being ripped off. Got a buzzer here. This is probably the display driver, main microcontroller, some LEDs for the light and for the display. This is the high voltage output here from the transformer. It's got a couple diodes, a couple capacitors here, and then the terminals for measurement. Fuse. That's probably a resettable fuse, that one. More than likely that's a resettable fuse. As is this one over here. Category 4, 1000 volts, Cat 3. I guess that's AC and DC. Battery terminals connected here. We'll throw the back on it and put it back together, and this little demo will be, I'll finish up the demo. I like the fact that it uses rechargeable cells and that they are individual cells and not in a battery pack. Like a lot of things, most things they'll make up a battery pack, they'll spot weld the terminals together, and yes, you can make your own packs up if you've got a spot welder like I have, but it just makes it much more convenient if you have to replace the cells. You can just buy 3 regular cells. You know, they're lithium, but they're just 3 conventional cylindrical cells, and they can go in. Just pay attention to the polarity. One goes in, 2 of them go in positive facing up, and the one in the middle is positive facing down because they are connected in series. So these 2 are connected together and these 2 are connected together. That's your negative terminal, that's the positive terminal going to the meter. The fact that it does use lithium cells as opposed to, say, nickel metal hydride or alkaline cells, for example, it means that this thing's going to run for a while before you have to recharge it. We'll test a few other things with it before closing off the video. We'll check it for resistance, and we'll check the capacitors. I think it does capacitors. Just grabbing a random capacitor, we'll put it into capacitor test, and got to switch over which button does it. One of these buttons will do it. That one, that's capacitor test there. That button, select. Oops, might help if I connect it to the correct polarity. What does it tell me this one is? 327.4 microfarads, 325. It's a 330. But that's within spec. If I go to, say, 1000, $990. There you go. That's close enough. Well within the 10% tolerance. I think it's 10% on the low side and 20% on the high side is typically how they rate electrolytic caps. Pick a small one. This is a 1 microfarad. So it's measuring capacity, no problem. It's not an ESR meter, it just measures the capacity. Measure resistors. There should be 47K. Measuring 51, but it's a carbon resistor. So that's probably what it is. We'll verify it with the other meter. Yeah. 51.94, and on this one 51.96. So resistant wise, it's measuring good. Measuring LED, and yes, it does make the LED light. This is enough of a voltage drop. Telling me the LED has a 1.51 volt drop across it. So there's enough power put on here to measure LEDs. I will measure the junction of a regular standard bipolar transistor, or BJT, bipolar junction transistor, between the base and the emitter, 0.5 volt drop. And the collector, between the base and collector, a 0.5 volt drop. And then, of course, between the emitter and the collector, we should see open. And if I reverse the polarity and put the negative on here, because it's NPN, it will be open for both. And that's how you measure transistors and diodes with this meter. And like all the other meters, it's going to do exactly the same thing. I don't even know if I'm going to bother with the temperature probe, because we've done those before. It's just a thermocouple, and it measures the temperature. Anyway, this was just a basic look at this new meter. Got it from Banggood. I'll put the link in the description. Neat features. That breakdown feature, I think, would be invaluable to somebody who's working on motors or transformers or anything that you would need to measure for breakdown of insulation. So it'll check wires, it'll check windings, so forth, and give you the relevant readings that are required for certification and safety. Anyway, thanks for watching. Links in the description. We'll catch you in the next one. Bye.